Good day grade 6 learners. Welcome to our lesson for Mathematics 6. Term 1 Week 1. Day 1 and 2. Our topic for today is constructing tessellation. Please don't forget to like, share and subscribe. Thank you. Basis of our lesson for today. A. Content standards. The learners should have knowledge and understanding of the tessellation of shapes, translation, reflection, and rotation with shapes. B. Performance standards. By the end of the quarter, the learners are able to tessellate a surface using different shapes. Learning competencies and objectives 1. Explore whether or not a shape tessellates. Tessellations. Define tessellation and explore whether or not a shape tessellates. Illustrate translation, reflection, and rotation with shapes. Tessellate with translated, reflected, and rotated figures, shapes 2. Draw resulting images of shapes that undergo translation, reflection, and rotation. Translation, reflection, and rotation with shapes. 3. Tessellate a surface using different shapes, including triangles, squares, and rectangles. A. Activating prior knowledge. Day 1 to 2 short review. Activity 1. Instructions. Identify as many shapes as they can. The learners should have knowledge and understanding of the tessellation of shapes, translation, reflection, and rotation with shapes. Establishing lesson purpose. Unlocking content area vocabulary. Tessellation is an arrangement of shapes closely fitted together, especially of polygons in a repeated pattern without gaps or overlapping. Unlocking content area vocabulary A. Symmetry means that when figures are divided in half, one shape is identical to the other shape, that is, a mirror image of the other. If a figure does not have symmetry, we say that the figure is asymmetrical. B. A symmetrical figure is a figure that can be divided into two identical figures that exactly match. C. Line of symmetry is a line that divides a symmetrical figure into two identical figures. C. Developing and deepening understanding. Subtopic 1. Tessellations. Explicitation. Defining tessellation and when figures tessellate. Key ideas. 1. When a shape or a set of shapes is repeated over and over again, covering a plane without any gaps or overlaps, a tessellation is created. 2. Figures that tessellate can completely cover a surface. Explicitation. Defining tessellation and when figures tessellate. Key ideas. 3. Some figures can tessellate by remaining in one position only. 4. Some figures need to be flipped or turned in order to make tessellations. Worked example. Example 1. Tessellating a plane using triangles. Worked example. Example 1. Tessellating a plane using triangles. Worked example. Example 1. Tessellating a plane using triangles. Example 2. Tessellating a plane using squares. Squares tessellate by remaining in one position only. Squares can tessellate the plane in a way that they closely fit together without needing to be rotated or flipped. Example 3. Tessellating a plane using a hexagon. Hexagon tessellates by placing them side by side and filling the plane. Example 4. Tessellating a plane using two figures. Example 5. Tessellating a plane using three or more figures. Example 5. Tessellating a plane using three or more figures. Example 5. Tessellating a plane using three or more figures. To understand what a simple polygon is, just think of it as a shape with three very specific superpowers. If a shape has all three, it's a simple polygon. 1. It has sides, straight lines. A polygon must be made of straight line segments. The rule: no curves allowed. Example: a square is a polygon, but a circle or a heart is not because they have curved edges. 2. It must be closed. Imagine the shape is a fence for a pet. If there is a gap anywhere, the pet can get out. The rule: every line must connect to another line at its ends so there are no openings. Example: a U shape is not a polygon because the top is open. 3. No crossing over. This is the simple part of simple polygon. The lines cannot cross each other. The rule: the lines only touch at the corners, vertices. They never intersect or make an X shape. Example: a star shape where the lines cross in the middle is a complex polygon, not a simple one. Think of polygons like a team. For a team to be regular, everyone has to be exactly the same. If even one thing is different, the team becomes irregular. Here is how to tell them apart. 1. Regular polygons, the perfect shapes. A shape is regular only if it passes two tests. Test 1, equal sides. Every single side must be the same length, e.g., all are 4 centimeters. Test 2, equal angles. Every corner must open up at the exact same angle. Example from your image, the regular octagon. Notice how it looks very balanced and symmetrical. If you turned it, it would look exactly the same from every side. 2. Irregular polygons, the unique shapes. A shape is irregular if it fails either of the tests above. If one side is longer than the others, it's irregular. If one corner is wider or sharper than the others, it's irregular. Example from your image, the irregular heptagon. Even though it still has 7 sides, they are leaning in different directions and have different lengths. It looks tilted or squashed compared to a regular one. This image explains a secret math trick. When a shape looks too messy or complex to measure, you can solve it by turning it into a shape puzzle. Think of it like playing with Lego blocks. Here is how it works. 1. Breaking it down, decomposing. In the middle of the image, you see a strange, wavy green shape. We don't have a single formula to find the area of a wavy green thing, right? The solution. We break it apart into smaller pieces that we do recognize. As the arrows show, this big shape is actually made of 1 hexagon, the 6-sided block, 2 triangles, 1 trapezoid, 2. Putting the pieces together, the formula. Once you have the smaller pieces, finding the total area is as easy as adding up your grocery bill. The rule: total area equals area of piece 1 plus area of piece 2 plus area of piece 3. In this specific example, total area equals area, hexagon, plus 2 times area, triangles, plus area, trapezoid, $3. Why this matters in tessellations: look at the colorful pattern on the left. It looks complicated, but it's just the same puzzle, repeating over and over again. By understanding one small unit, the green shape, you can understand the whole huge wall or floor pattern. This is called spatial reasoning, the ability to see how small parts fit together to make a big masterpiece. Lesson activity. A. Tell whether the figures below can be used to tessellate a plane. Answer even numbered items only. Answer 1. Cannot tessellate. 2. Can tessellate. 3. Cannot tessellate. 4. Can tessellate. 5. Can tessellate. 6. Can tessellate. 7. Cannot tessellate. 8. Cannot tessellate. 9. Cannot tessellate. 10. Can tessellate.